All right, so for those of you starting chapter 9, chapter 8, we had talked about polynomials and how to work with polynomials, factoring, all of that lovely stuff. Now we're going to go into a specific type of polynomial, the quadratic function. So if you remember from 8.1, that first section where we talked about naming polynomials and that a quadratic was when we had a degree 2, we're working with all functions that have a degree 2. So as we get started here, our first lesson is just talking about quadratic graphs. So lots of vocab here to begin with. If you need to pause, write. You can come back and listen if you need to after you write it. So a quadratic function is a type of nonlinear function, nonlinear being not a line, that models certain situations where the rate of change is not constant. So a quadratic function is considered y equals ax squared plus bx plus c. Only thing is a cannot equal 0. The reason is if a equals 0, then we have no x squared, right? And that's what makes it a quadratic. If it was just bx plus c, then that would be a linear function. So we need that ax squared. Standard form is written right here. Y equals ax squared plus bx plus c, again, where a does not equal 0. So on to the next set of vocabulary. So the parent function, any parent function is the simplest function, right? For a linear parent, it's y equals x. That is the simplest linear equation. So for the quadratic, it's just y equals x squared. That is the parent function. Everything else is derived from that function. The graph of a quadratic is called a parabola. That's the U-shaped curve. We have what is called an axis of symmetry. That's a line that divides the parabola into two matching halves. So quadratics are symmetric. We can't say lines are symmetric because there's no middle to fold the line in half. But, excuse me, we can fold a parabola in half. And it's because it's a U shape. So we have that axis of symmetry. And then what we have is the vertex. This is going to be our highest or our lowest point on the parabola. And just to make things easier for you, if a is greater than 0, so positive values, it's going to open up. This type of vertex has a minimum point, and if a is less than 0, so negative a values, it's going to open down. And the vertex is a maximum point. Now, one of my high schoolers back in the day when I was teaching this, the way they remembered it was positive, happy, so the U was like a smiley face, with minimum problems. And that negative was sad face, maximum problems. That was the way they remembered it. So if that helps, use it. If not, no harm done. All right, so let's actually use some of this vocabulary. What are the coordinates of the vertex of each graph? Is it a minimum or a maximum? It's as simple as go to the top of your U or the bottom of your U. Of course, I tried to draw a dot and it wants to be all picky, right? That point, or over here, this point, those are our mins and our maxes. So for A, our vertex is sitting at the point 0, because it's on the y-axis, 0, 3. And then because it's at the top, this is a maximum value. All right. If we look at B, our vertex is at the bottom of the U, right? So here we have vertex. Our vertex is at the point 1 comma negative 1, right? And then it's at the bottom of my U, so this is a minimum value. So A is opening down, so we have a maximum. B is opening up, so we have a minimum. What this would tell me is that A's graph would have a negative A value in front of that x squared, and B's graph would have a positive A value in front of that x squared. So that's where we're going to end this video. The next video, we're going to go into how to graph and compare graphs. I will see you there.